All right, so we tend to think of AI as this all-knowing oracle, right? You ask it a question, it gives you an answer. But what if that's the wrong way to look at it? What if the real game changer isn't teaching an AI what to think, but how to think? That's what we're diving into today. Okay, so take a look at this math problem on your screen. I mean, it looks pretty gnarly, right? You've got fractions, polynomials, even pi in there for good measure. You'd assume our super smart top-of-the-line AIs could just knock this out in a second. Well, what if I told you they can't? Yeah, you heard me right. The research we're digging into shows that even the heavy hitters, we're talking GPT-4o, Claude, they consistently fail this problem. They either just get completely stuck, or worse, they give you an answer that's confidently totally wrong. And this isn't just some random bug. No, it's a huge clue that points to a fundamental limit in how these AIs actually reason. So, what is going on here? This failure is actually a huge window into a surprising blind spot for AI. And to really get our heads around it, we're going to borrow a really cool concept from human psychology. It frames this whole thing perfectly. So, psychologists often talk about these two different ways our brains work, System 1 and System 2. System 1 is that instant gut reaction thinking. You see a face, you recognize it. It's fast, it's automatic. System 2, well, that's the total opposite. It's the slow, deliberate, heavy lifting kind of thinking. It's what you use when you're solving a tough puzzle or planning out a big project. You know, the kind of thinking that actually takes real effort. And here's the kicker. This is exactly what's happening with AI. Our current large language models, they are absolute geniuses at System 1. They're basically prediction machines, guessing the next word with lightning speed. It gives them this incredible, almost intuitive feel for language. But when it comes to that slow, methodical System 2 work, they really struggle. They can't just intuit their way to the right answer for that math problem we saw. So, okay, how do researchers try to fix this? Well, for a while now, they've had a pretty clever trick up their sleeve to try and, well, coax a bit more of that deliberate System 2 style thinking out of these models. It's called chain of thought, or you'll see it as COT. And the idea is actually pretty simple, but really powerful. Instead of just asking for the final answer, you tell the AI, hey, show your work, think out loud, step by step. It's basically like giving it a recipe to follow. And by breaking the problem down into this nice, neat, linear sequence, a lot of the time the AI can follow those steps and get to the right answer. But, and this is a big but, chain of thought has a major weakness. Don't get me wrong, it's a huge step up, but it really only works when there's a clear, straightforward recipe for the problem that the AI has already seen, in its training data, like a standard textbook problem. So what happens when you throw a problem at it where there is no simple recipe? Let's look at a kind of problem that just completely shatters this recipe-following approach. It really shows you where the cracks are. This is the windmill problem. It's kind of infamous. It's from the International Mathematics Olympiad. And what makes it so tough isn't that you need some super advanced calculus or anything. It's because the path to the solution is just not obvious at all. There is absolutely no textbook recipe for this one. Yeah, see, solving the windmill problem isn't about following some nice, neat line of logic. The actual humans who managed to crack this thing, they used a really messy process. We're talking exploration, lots of trial and error, hitting dead ends, and then finally having this creative leap. That whole process looks nothing like a clean, step-by-step chain of thought. And that brings us to the absolute core of this new research, the breakthrough idea. What if, instead of giving the AI the recipe, we could teach it how to create the recipe? What if we could actually teach it that messy, human-like process of how to think? This new approach is called Meta-Chain of Thought, or Meta-CoT. And that word meta is key. It means about. So instead of just spitting out a chain of thought, the AI is learning about the process of creating one. It's learning how to explore different paths, how to try stuff out, and, crucially, how to recognize when it's gone down a wrong path, go back and try something totally different. And you can think of the difference like this. Standard chain of thought, that's like a line cook following a recipe they've memorized. It's fast, it's efficient, but only for dishes they already know. Meta-CoT, though, that's like a creative chef. A chef who understands the principles of cooking and can experiment, play around, and invent a brand new recipe from scratch. It's slower, yeah, and way more deliberate, but it's so much more powerful. So what does this actually look like in practice? Well, it's not a straight line at all. It's more like a search. Let's go back to that first math problem.
If we could peek inside the AI's mind now, we'd see it start down one path, kind of exploring an idea, maybe thinking to itself something like,
But then it hits a wall. It realizes, okay, wait, this isn't working. This is a dead end. And instead of just plowing ahead blindly, it does something totally new. It stops, recognizes the mistake, and it actually backtracks. It's this moment of deliberate pause and reassessment. And after it backtracks, it can go back to a point where things were still making sense and try a totally different angle. This right here, this is where the magic happens. This ability to explore, to fail, and then to self-correct, I mean, that's what real problem solving is all about, right?
and the amazing thing is, the data shows this actually works. Look at this chart. It's from an analysis of one of OpenAI's model series O1, and it's pretty wild. On the left, you've got your standard AIs. They use fewer thought tokens. You can just think of those as units of thinking effort, and their accuracy isn't great. But on the right, the model trained with this new meta approach uses way more thought tokens, is literally thinking harder about the problem. And look at the result. The accuracy is way, way higher.
So what this tells us is that the model has actually learned how to adapt. When it gets a hard problem, it dedicates more computational power to exploring and checking its work. It's not just guessing faster anymore. It's actually engaging in that slow, deliberate, careful process. This is it. This is probably our first real glimpse of an AI doing genuine System 2 reasoning.
This is obviously a huge leap, but what does it all mean? What are the bigger implications of teaching an AI how to think? You know, the researchers who did this work brought up that old proverb, and it just captures this shift perfectly. Give a man a fish, you feed him for a day. Teach a man to fish, you feed him for a lifetime. And for years, we've just been giving AI fish. We've been feeding it millions of correct answers. But now we're finally starting to teach it how to fish. We're giving it the actual reasoning skills to go out and find the answers for itself. So let's just recap the big takeaways here. First, AI is evolving from just being an answer engine to becoming a true reasoning engine. Second, we've learned that this thinking process isn't a straight line. It's a messy trial and error search. Third, this could be the key to unlocking AI solutions for problems in science and math that are currently way beyond our reach. And finally, and maybe most importantly, this is the first real tangible step towards an AI that has genuine System 2 thinking abilities. And all of this leaves us with one last massive question to think about. If we can really, truly teach a machine the process of discovery, not just have it memorize the answers, what could it solve next? What challenges that seem impossible to us today might become solvable tomorrow? And that, right there, is why this is one of the most exciting things happening in AI right now. Thanks for digging into this with me.